Yeah, I think I'll show. There's a short video also of Dan talking about his experience. Yep, that was that one. So this is Dan Price after he came back from the base.
I recently last summer took part in the first major traverse that New Zealand has mounted across the Antarctic since Hillary did it in the 1950s. The amount of planning that goes into the traverse is pretty incredible. So it's a 2-year planning phase with the logistics that happens, and then I was involved for about 6 months before using satellite imagery to plan the whole route. Of course, Hillary and all his boys didn't have any of that, so we've got this amazing satellite resource that we can use to get imagery of where we're going and sort of locate all the hazards. And the major hazards are crevasses. So the whole objective is not to drive into one of the crevasses, and these satellites really provide an amazing tool to do that. We also have a radar mounted on the front of the first vehicle, which is an incredible tool because it gives us about a 4 or 5 second warning if a crevasse is coming up ahead of us. So one of us is driving in that vehicle and the other one is continuously monitoring that GPR, ground penetrating radar system, and then we can get a really good idea of what's coming up ahead. All we're trying to do is prove a route so that the science can be done at specific sites. And there is thought in the future that we might use the actual traverse route to do some science too, so drag instruments with us and kind of have a sort of circus of scientific instrumentation on tour in Antarctica.
So I wanted to talk to you a little bit about just a few more things of the current experience. One thing to know is that these kind of traverses are really a limiting factor on what science is being done in Antarctica. They have lots of places where they want to have drilling sites and scientific stations, but every traverse is just such a major operation that they have to pick and choose, individually ones to go. They had there's one area that is really difficult to get to on the coast. That is, they had a team of 60 people trying for 4 years to get there, and they couldn't get there, and so. It's just and that's one of the most critical spots for monitoring sea level rise potential for from Antarctica.
Eric, I know this will probably be a silly question, but why can't they fly?
That particular area that they were going to, well, actually they could fly a certain range. Like they have helicopters that can get you to a certain range. This one was out at the range where they could get with some aircraft, but it's also limited with their aircraft resources as to which ones can land on unprepared surfaces like this, or if they get people out there in one way, they can start to make a runway, but it's also, they basically need a large team out there, getting them out there in another way before they can even get the aircraft to land there. And that one spot they were trying to get to has is one of the only spots that gets a huge amount of snowfall, and so 2 meters of snow each season. So it's it wipes out any kind of prepared setup they have before. This is our analogy with in The Martian with, I got the author of The Martian to wish Dan well before he left because his traverse is almost exactly like in the movie. But we do have one of our advisors is the expert on, we're involved in the Martian rover program where they do a lot of analysis and planning of just to get the Mars rover from one spot to the next because of the little wheels on the rover can't handle very much in terms of obstacles. So there's so these kind of navigating through hazards is going to be a continuing issue on the Moon and Mars. The Moon has a real challenging environment with shadowed craters and things like that we want to go into, but it's going to be really difficult to run in there and not get stuck at 40 Kelvin. One thing about Antarctica is that you may get maps to help you prepare, but the landscape is not going to give you many clues about what the hazards are that you're crossing. And this is on a clear day. Some of the from Alan Gray's some of the problems not only are in the lack of communication systems. There are iridium satellite phones that will work, but you have to be outside. You have to well, like Alan was describing, not being able to use the phone without taking your gloves off and having the phone only operate for about 5 minutes before the battery will die. But there's also the magnetic pole is so far different than your compass is pretty far off. But GPS will certainly help you, but also you have to keep in mind that on the ice shelf that the ice is moving like 1 meter or 2 a day, and so they've had problems in the past with aircraft coming in to land on a runway that has moved half a block in the wrong location. And the humidity, it's strange because it's extremely low humidity, so that just walking around inside the vehicle, you can build up static charge that can fry a lot of electronics, and they actually, strange to think, but in their computer rooms they actually humidify the inside to try to contain the sparks. And of course the temperature and wind can reach extremes, and in some way the holy grail for this is going to be if you can actually do any of these traverses during Antarctic night, during Antarctic winter, because right now to go out and clean off a sensor is a major operation of weeks of planning, and so much of activity, the scientific activity, shuts down, during the darkness, the 6 months of darkness. And battery systems, you can get batteries to work at low temperature, but you can't charge them unless you warm them up, and so that's an interesting aspect if you're actually trying to fly drones or things like that. So we saw this before with the kind of crevasse, and on the ice shelf this can go down like 50 meters or more. So here's here's where the Scott base is near U.S. McMurdo Base, and this was the ice shelf traverse. And it was out here that they've been trying to get to. That is such an extreme case of where there's an entire glacier into the ocean there that they're trying to monitor the speed of the glacier. And it's this is if these ice shelves actually melted completely, this would be how much sea level rise you get. So, so if this starts to melt, then that's when you lose Venice, Miami, and New York, and et cetera, and here too, and Auckland.
Here.
So anyway, it's a lot of this is trying to monitor it's how much these ice shelves are speeding up, as well as it drives entire circulation of the ocean with the change in salinity and temperature, and so it's very strange that a small change in Antarctica can change the climate in Europe just through the ocean circulation. And here's where their attempt to drill through the ice, through the water, and then into the mud, which has a record of the last 1,000,000 years of the motion of the ice sheets. And once again, this is that where the Ross Ice Shelf. This is also where the race to the South Pole occurred. So apparently Commander Scott is. Tent is stuck in the ice about 70 meters down now. This is their current scheme with dragging the equipment with the vehicle up front, finding the path, checking for crevasses, and it's in some ways it's the worst kind of human factors of where if you just a lapse of intention would mean that you don't know if you were going this way and you suddenly are headed the wrong way, and you're not getting, you have to wait until you've traveled a certain distance for your GPS to tell you whether or not you've deviated from your course. This is once again the hand-drawn or hand annotated map of the crevasse fields. And this is their attempt to get as much satellite data as possible. If the snow cover on the crevasse is slumped a little bit, you can see it in visible images like this. And so you can see, but oftentimes it's just completely flat and there's no data on the visible image. And so then you use the synthetic aperture radar data, which can show you the crevasse fields, and here's that one that they were monitoring while they were driving. In order to avoid all of this, they went way down here in this way, angling through the curved ones here, and then angling through over here, even following the little bump here of these curves of the crevasses, and in order to get to a clear spot out here. So it's there's new synthetic aperture radar satellites that have been launched last month, and I don't think anyone has asked them about their coverage in Antarctica. So that's an example of there are new systems coming online. Can any of this help? We're collecting information about accessing the ESA satellite data, and I hope that since they have records of the entire time that Dan was down there, I hope it'll show up his tractors and the little bright spots in the radar data. But yeah, this it's about as challenging a landscape as you get for trying to find where these hidden hazards are. And they were able to fly drones, and so we're getting some information that way, but oftentimes the weather just doesn't allow. There's the radar, and there's the human factors of, here's the satellite data map, and here's the horizontal lines from the ground penetrating radar. And Dan was describing just staring at this for 8 hours and looking and hoping to see if I catch a little glimpse of a vertical line there that might be deadly and with a 4-second warning.
Can I have a question? Is the data for available for that that route?
Yeah, that's a
Did they
good question.
say-
Yeah, that's yeah, exactly the kind of thing we'll be investigating. I'll be asking Dan about that. The state, we need to document the state of the art